All right, so again, the key to starting any of these questions is drawing the diagram. The key to getting the questions right from that point is making sure that your diagram is drawn correctly. Usually drawing the diagram wrong from the beginning is just bad luck from then on. So here we go, we've got a spotlight on the ground. So we're going to draw that spotlight on the ground here. We're gonna really make it pretty. Oh, nice. So there's our spotlight on the ground. And a man 2 meters tall, so really pull out our skills, walks from the spotlight towards a wall, because everybody likes to walk towards walls. At a speed of 1.2 meters per second. How fast is his shadow? Oh, it's a tall wall. Let's keep making it go all the way up. Because we would have brilliant light shining all the way to the top. That's really yellow. Can you see that? Probably not. We'll pretend there's some green tinge to the light to make it pretty. So there's the shadow on the wall. Oh my goodness, I'm not allowed to use my creative pen. I forgot. So what happens here is there's a triangle, a big triangle here, created by the shadow and the person. And there is another triangle here, created by the person. What we know is that the height of this person always stays at 2 meters. What's changing is this person is walking this way towards the wall. As he walks that way towards the wall, you can see that the shadow is going to be going down. We want to find out how much this shadow is going down, so it makes sense to label this side as, say, y, because it's up and down, and say, well, I know y is a function of time, and I want to find dy dt. We know that the spotlight itself is 10 meters away from the wall. We have to decide what we're going to make our x. And we have two options here. We can either make our x represent the distance from the spotlight to the person, or we can make our x the distance from the person to the wall. Whatever we decide, the other space will be 10 minus x. If I were doing this and I was trying to make it, you'll get the right answer whether you put it here or here. What's going to change is whether your dx dt is positive or negative. Can you see that if I have the x where it is right now, as he walks towards the wall, that x will be getting smaller? Then you would need to make your dx dt negative 1.2. If I have my x here, as he walks towards the wall, my x will be increasing. Then my dx dt would be positive. So I'm going to keep it there because I like using positive numbers more than negative numbers. That makes this 10 minus x for that part. And my dt will be a positive 1.2 meters per second, which tells us that x is also a function of time. We know nothing about the hypotenuse here, and we don't need to know anything about the hypotenuse. For this one, the key to it is to recognize that the red triangle and the blue triangle are similar triangles. So their ratios of their sides are going to be the same. So what that means in our red triangle, 2 over x has to equal in our blue triangle, y over 10. What I just did is I made an equation that has both x and y. I'm going to simplify that equation so it doesn't have any fractions. Multiply both sides by 10, both sides by x, and I'll get 20 equals yx. Now we have an equation, so we can take the derivative with respect to time. How about I do the left side, you guys do the right side? Okay. That was a bad joke, I'm sorry. Derivative of 20 will just be 0. What do you have to do on the right side? Product law, product rule with implicit differentiation. So we do derivative of one, keep the other one the same. So if I keep y the same, derivative of x is just dx dt. Plus now I'm going to keep x the same, derivative of y is dy dt. Now we want to find out how fast when he is 3 meters from the wall. So in that situation, this part here is 3, which would make this part 7. Still 2 meters tall, so the ratio of 2 over 7 has to equal y over 10, which tells us that y is 20 over 7 at that moment. So putting things into our formula now, y is 20 over 7. dx dt was 1.2. When x was 7. This is where sometimes you get confused because the question said 3 when he's 3 meters away from the wall. You have to make sure you go back to your diagrams. Where did I place my x? My x would be 7 in this case, and dy dt is what we're trying to figure out. Moving things over to the other side, 20 times that will be 24 over 7. Negative equals 7 dy dt. Divide both sides by 7. And negative 24 over 49 units were meters per second. So just a little bit less than half a meter per second is how fast that shadow is decreasing on that wall at that moment. So we're going to take the rest of the class to get you started on some on your own. Homework is listed at the bottom.